Well, hello and welcome to World Mycotoxin Report Impact 2019, a webinar hosted by BIOMIN and Romer Labs. Both companies are part of the ERBA group, and we're broadcasting live from world headquarters in Austria. Welcome. My name is Joshua Davis, and I'm the Communications Manager at Romer Labs. And joining me are Alexandro Marchioro. Hello.
Hey,
how are you doing?
Fine, and you?
I'm great. Alex is Senior Mycotoxin Expert and Product Manager at BIOMIN. And also joining us is Martina Bellasio. How are you doing?
Hi, fine. You?
Doing great. Glad you're here. Martina is also Senior Mycotoxin Expert and Product Manager at Romer Labs. I know that you're all eager to hear the results from the BIOMIN World Mycotoxin Report, but first, a few important words to our audience. I just want to remind you that this is an interactive webinar. When you open the toolbar on the right-hand side of your screen, you'll find a chat function for issues regarding audio, visual, or other technical settings within the webinar platform. The questions function can be used at any time throughout the session, so please feel free to enter questions for our speakers and for the Q&A session later on. In addition, you, the audience, can also vote in several polls throughout today's session. When I announce a poll question, you'll have the opportunity to provide your input in real time, and then I'll announce the aggregate results. So without further ado, let's start with our first poll question. Here we go. Very simple question to get us into the topic. Have you found mycotoxins in your raw material or finished feed in the past 12 months? Yes, no, or you're not sure. While our audience members select their answer, Alex, would you remind us of the relevance of mycotoxins to feed and farm animals?
Yes. Well, there's a quite broad spectrum of effects caused by mycotoxins. What is really important to know is that all mycotoxin, even at a low concentration, can cause important losses. Especially in the last 5 years, a lot of studies were published showing the negative effect of mycotoxins on the gastrointestinal tract. So this can be the starting point for several intestinal diseases. And moreover, they can also be toxic to the liver, impair reproduction, and in case of a high contamination, cause neurotoxicity and carcinogenicity. And all of these effects will decrease animal performance, of course, and will be directly reflect in economic losses for the livestock industry. So this costs billions of dollars each year.
Billions?
Yeah.
Well, that's quite a lot. Now we're closing our voting right now. Thank you for voting. And having a look at the results. Wow, that's pretty clear. 81% of you are saying that mycotoxins are an issue for you. Only 7% are saying no, and the rest of you are saying you're not quite sure. So what do you think about these results, Alex?
Well, this is not a surprise. At BIOMIN, we have been helping clients cope with mycotoxin challenges for over 25 years. So our research and the animal survey program show that mycotoxins are indeed a common issue in the animal feed. Yeah.
All right. You've brought a preview of this year's BIOMIN mycotoxin survey results. Let's have a look at the numbers, why don't we? Now, BIOMIN has been running this survey every year since 2004. In this year, you tested 18,424 samples of finished feed and raw material, sourced from 79 countries. Tell me, what's the picture look like globally?
Good. Yeah. Let me know. Since 2004, BIOMIN has published this mycotoxin report. So it provides the market with a strong tool to measure mycotoxin risk. So it's also important for us because it's helped our technical and sales team recommend solutions for mycotoxin-caused problems. And so now let's have a look on the worldwide contamination. So first of all, I would like to explain how to read this map. In this world map, the subregions of the world are colored according to the percentage of samples above the risk thresholds.
You say risk threshold. What exactly do you mean by that?
Good. These risk thresholds are defined by BIOMIN with the worldwide practical experience in the field and scientific trials, and according to the literature also. So yellow means moderate risk, up to red represented the extreme risk with more than 75% of tested samples above the risk threshold. So when we take a look the average contamination levels in the worldwide results from 2018, we can see that 62% of feed materials had at least one of the major mycotoxins present, at a level that we know that could affect animal health or performance. In addition, we can see that all regions are affected by mycotoxin. And of course, for the full details in this world map, the webinar participant will receive a link to the BIOMIN World Mycotoxin Survey 2018 in the next 24 hours.
That's right. We've got a lot of goodies coming your way, so be sure to be checking your inbox for that. Now, Alex, today's session is billed as the impact of mycotoxins in 2019. So according to your analysis, what are the trends in regards to the most prevalent mycotoxins?
Okay, well, we can see one example here, the trend in the occurrence of FUMONISINS and DEOXYNIVALENOL in corn on this slide. So the bars represent the prevalence, and the line represents the average of contamination in ppb over the last 10 years. So we can see that the co-occurrence of these two mycotoxins is high, and also the average of contamination can cause expressive losses on animal production. This is specifically true of the most sensitive phase, like reproduction and starters.
So could this trend also be observed for different regions worldwide?
Yes, for sure. We have observed this trend on nearly every continent. So to discuss a bit more about the mycotoxin occurrence, so how is the main factors or the main point that we need to consider at the moment? There are many factors that influence mycotoxin occurrence in general, but for example, we know that the climate change will decrease yields. And also environment stress has been shown to have a significant consequence for fungi growth, especially increasing mycotoxin production. Furthermore, extreme drought episodes like desertification, floods, and fluctuation between wet and dry cycles have an impact on the life cycle of mycotoxin producing fungi. So weather conditions at a certain growing stage, for example, flowering and harvesting, definitely influence mycotoxin occurrence. And to illustrate the impact of the weather during the harvesting period on mycotoxin formation, I have brought one example here. So here are some image of the harvest conditions in parts of Argentina in 2017 and 2018. There was heavy rainfalls in 2017, causing flooding, and as you can see, the corn was totally submerged. And the data about the corn in Argentina during the harvest season show a high risk, especially in fumonisin contamination, as more than 2/3 of samples tested were above the risk threshold and showed an average around 3,500 ppb. However, in 2018, Argentina experienced a long dry period. Looking again at the corn data after the last harvest, we could observe a high fumonisin contamination with an average around 4,700 ppb. So we can see that the impact on climate and the weather condition on the level of mycotoxins.
So you're talking about a couple of different mycotoxins here. You're talking about fumonisin and DEOXYNIVALENOL. Do these occur in similar patterns everywhere, or is there some geographic variation?
Okay, let's talk the data region by region. We have separate maps for each region that show the sub-region risk. So let's start with Europe. In Europe, the most prevalent mycotoxins are deoxynivalenol and fumonisins. In corn, 74% of sample tested positive for fumonisins. In cereals like wheat, barley, etc., deoxynivalenol contamination was high, with 912 ppb on average. In Southern Europe, 84% of all tested samples were positive for FUM. Moreover, in Central and Northern Europe, the occurrence of the deoxynivalenol toxin increased in 2018. In Central Europe, the prevalence was at 64%, with an average of 700 ppb. And Northern Europe showed similar levels to DON, with a prevalence of 66% at the average of 724 ppb. So these results show us the mycotoxin contamination can change between the regions, depending especially on the weather and grain production conditions, right? So let's now discuss how these results treating animals. First of all, I would like to explain how to read the graphic on the right side. The gray bars indicate the proportion of samples with each mycotoxin detected on all analysis performed. The pictures of animals are colored according to the proportion of samples above the risk threshold for each animal species. So DON is one of the main concern in all species. As in 2017, in 2018, FUM and DON were the greatest mycotoxin of concern. So both of these mycotoxins are frequently found at a level of concern for swine and poultry. For the other mycotoxin, the risk levels were quite moderate, right? Going to North America. In North America, we observed a rise in DON contamination, especially in cereals, from 65% in 2017 to 86% in 2018, with the average of 1,800 ppb. And also fumonisins were present in 70% of corn sample analyzed, with a high average of 3,400 ppb. And another important corn subproduct, the GGGS, was especially subject to DON contamination. So the prevalence was at 98%, and there was average contamination of 1,400 ppb. So we can see, DON and FUM were the highest threats in this region. And in addition, we know that these two toxins can work together to make things even worse for the animal performance. Looking now South and Central America, in this region, the risk was high. And Central America had a risk level of 70%, while South America had a risk level of 72%. And DON is present in 88% of cereal samples. They tend to test at high average concentration with around 1,900 ppb. Further, a maximum concentration of 8,700 ppb was detected. And again, FUM is the most abundant mycotoxin in this region. It contaminates 86% of corn, 100% of GGGS, and 89% of finished feed samples. As concentration as high as 72,000 ppb of FUM was found. So FUM contamination was particularly high in Argentina, owing to the weather condition we showed before. So FUM was high at 4,700 ppb on average. So in Central and South America are showing a high risk for all animal species. Again, DON and FUM were occurring at the levels high enough to represent a real threat. Looking for Asia, in general, Asia has seen a high risk level in this year. In contrast to the other regions, there were other concerns aside from FUM and DEOXYNIVALENOL. So aflatoxins was present in 44% of all samples tested in this region. But moreover, in South Asia, 87% of samples contained aflatoxin. It occurred mainly in finished feed samples. In China, FUM and DON were very prevalent, particularly in corn, and 96% of corn samples were contaminated with these two mycotoxins. So FUM returned an average of 3,400 ppb, while DON levels came back at 540 ppb. So about the Middle East region, in this region, the total threshold risk level is at 60%. In particular, the prevalence of FUMONISINS, DON, and zearalenone, sorry, it's on the rise here. By taking a closer look at corn samples, we can see 100% prevalence of FUM with the average of 3,100 ppb. So overall, the risk remains high in this, poses a genuine risk to the animals. And the last region that we want to show, it's Africa. In Africa, we see a high contamination of three mycotoxins, DEOXYNIVALENOL at 84%, FUMONISINS at 77%, and zearalenone 72%. So let's have a look at the result for animal species in Africa. DON and FUM occur here at the most, but it's important to keep an eye on zearalenone levels in some areas, right? So these overall results include South Africa, of course, and we have to keep in mind that most samples originate from there. In addition, this region generally doesn't show levels as high as in other parts of Africa. So these were the highlights from the region that we planned to show today. But remember, for more details about the regions, we will send the full mycotoxin survey in the next 24 hours.
All right. Thank you, Alex. Thank you for all these insights from region to region. Now, the high prevalence of mycotoxin occurrence that you showed us makes it even more important, in my opinion, for feed and grain producers to test for mycotoxins. And this, I think, is where the experts at Romer Labs might have something to tell us. But before I hand it over to Martina, let's open up for another poll question. So here we go. Poll question number 2. How many mycotoxins do you test for? 0, 1, 2 to 6, or more than 6? Now, while our listeners are responding to the poll, perhaps you, Martina, can tell us a bit about Romer Labs. Romer Labs has testing solutions for other analytes, such as pathogens and GMO, but it began as a mycotoxin testing company, didn't it?
Yeah, that's true. Mycotoxin has been really at the heart of Romer Labs since our beginnings in 1982. And we really started out with mycotoxins, and now with more than 35 years of experience in this field, Romer Labs features the broadest portfolio of mycotoxin testing solutions on the market, including on-site screening methods and reference testing methods to be applied in the lab.
Okay, thank you. So now let's close that poll out. And thank you for your responses. Now they're coming in. Well, the vast majority of you, 66% of you, answered the third answer, 2 to 6 mycotoxins that you test for. 9% of you said 0 mycotoxins, 6% of you said 1, and 18% of you, which seems to be a surprisingly high number, test for 6 or actually more than 6 mycotoxins. What do you think about that, Martina?
Yeah, this corresponds to what we know from our customers, because on average we have 6 regulated mycotoxins, so these are the ones most commonly tested for.
So what actually are the mycotoxins that people usually test for? And are there others aside from the usual suspects, so to speak, that we need to keep in mind?
Yeah, this is a good question. Here you see the most commonly tested mycotoxins. So the BIOMIN survey has given us insight into the incidence of these 6 major mycotoxins in agricultural commodities. And for these 6 well-known toxins, much toxicological data has been collected in the past decades. But in the last years, the attention of the scientific community has also been focused on several other fungal metabolites, and more evidence on their toxic effects is being collected. We actually use the term emerging mycotoxins to underline how these analytes have been gaining awareness in the analytic community. Here you can see the toxic effects of some of these emerging mycotoxins. They have all been linked to some sort of toxic effects. So patulin and bovaricin both negatively affect the immune system. Fusaric acid has negative effects on the swine nervous system, and ergot alkaloids are a special class of compounds that cause fat necrosis and reproductive dysfunction, while moniliformin is particularly toxic to the heart. Other toxic metabolites that have gained more and more attention in recent years are the so-called MAIZE mycotoxins. And in the following slides, I would like to tell you a bit more about these toxins. So when fungi infect a plant, they release a wide range of metabolites, including the well-known DEOXYNIVALENOL and zearalenone as part of the natural infection process. Often, the plant host will modify the compounds coming from the fungus. This chemical modification is the so-called mask that hides the true identity of the mycotoxin. And this is why traditional mycotoxin tests often miss them. But for the plant, this masking represents a detoxification strategy. And usually a glucose molecule or a sulfate group is attached to the fungal metabolites. The problem is that the toxicity to humans and animals will re-emerge when the attached masking group is cleaved off by the bacteria in the gastrointestinal tract of mammals. And this is of particular interest given that novel plant breeds selected to be resistant to mycotoxin-producing fungi often accumulate a higher percentage of MAIZE mycotoxins compared to the non-resistant variety.
So in addition to the 6 regulated mycotoxins that you showed us earlier, we also have emerging mycotoxins and masked mycotoxins to worry about as well. Tell me, what are the effects of multiple mycotoxins in feed?
Yeah, well, we have already heard from Alex that agricultural commodities are often contaminated with more than one mycotoxin. And this is, of course, true not only for the regulated mycotoxins, but also for emerging and masked mycotoxins. Now, in this slide, I would like to remind you what types of effects that we can have when 2 or more mycotoxins are present in the same sample. So in general, there are 3 different types of effects: additive, synergistic, or antagonistic. The toxicological interactions between mycotoxins are typically synergistic. So this means that the effect of 2 or more mycotoxins present in the same sample will be higher than the sum of the effect of the individual mycotoxins. The synergistic effects can vary from animal to animal, and they can also be very complex to investigate. But in this slide, we can see some examples of synergistic and additive effects in 2 different species. Synergistic effects are indicated with red lines, and additive effects are indicated with dashed lines. And the figure on the left-hand side refers to poultry. For example, here we can see that fumonisin B1 exhibits synergistic effects with fusaric acid, an unregulated mycotoxin, with additive effects to T2 toxin, another regulated toxin. On the right-hand side, we have instead data for swine. And here, fumonisin B1 has synergistic effects with aflatoxin B1 and deoxynivalenol, for example. So far, I would say we have seen 2 concepts, that there is increasing evidence that many fungal metabolites have toxic effects on animals, and that the simultaneous presence of several mycotoxins can exponentially increase the toxicity of a sample. So an obvious question arises: how can we get information on the whole contamination level of a sample if the traditional rapid tests are available only for regulated mycotoxins? Well, analysts are increasingly turning toward a liquid chromatography tandem mass spectrometry as a method for detecting multiple mycotoxins in one sample. And in fact, analytical methods based on CMSMS have become a true state-of-the-art approach in the analysis of mycotoxins over the last decade. The advantages of a CMSMS include not only the ability to perform multi-mycotoxin analysis, but also its high selectivity and sensitivity, bringing its range of detection down to the PPT range for most mycotoxins.
PPT, does that mean parts per trillion?
Exactly, that's right. So here we can see an example of how an output of an CMSMS analysis looks like. The sensitivity and selectivity of the instrument allows us to identify and precisely quantify many different metabolites in just one run. Romer Labs offers the most comprehensive CMSMS multi-mycotoxin analysis commercially available. We call it MULTI-MYCOTOXIN Analysis 50+, and this analysis gives us a unique insight into the contamination pattern of a sample with more than 50 mycotoxins quantified. Our method is a key component of the BIOMIN Spectrum Top 50 service. And at this point, you might be asking how we chose which mycotoxin to include in this method. So here are the criteria we applied. Of course, all the regulated mycotoxins are included, together with the emerging and mass mycotoxins for which toxicological data is available. And last but not least, only toxins for which high-quality analytical standards are available were selected.
Thank you, Martina. But this raises one question for me, and Alex, you can also feel free to jump in here. We know that there are over 400 fungal metabolites out there that could be toxic to animals. How do we test for those that don't meet these criteria that Martina just showed for the 50 methods offered by Romer Labs or by BIOMIN? What do we do?
That's a good question, Josh. In our experience, there are always a few customers who can't get the root of their mycotoxin problem with our Spectrum Top 50. So to get these details, we use a method with the capacity to detect most of these 400 metabolites. So this state-of-the-art method can measure over than 380 mycotoxin and secondary metabolites. So we call it Spectrum 380, right? And to have a look at the spectrum result, we can see that the curve contamination where multiple mycotoxins are present is very common. And the most prevalent emerging mycotoxins are moniliformin, belvericin, eniatin, and coumarin. So we found these for the most part in wheat, maize, and finished feed. So we also use the Spectrum 380 as part of BIOMIN survey, and we analyzed in 2018 691 samples. And have a look at the graph on the left. On the x-axis, we have the metabolites per sample, and on the y-axis, we can see the proportion of a sample in percent. So most of the samples contain between 20 and 29 metabolites. On average, we detected 34 metabolites per sample. And we also observed that 9.7 out of 10 samples were contaminated with fusarium toxins. And finally, we can also see that 98% of all tested samples were contaminated with more than 10 different toxins and metabolites. Okay.
All right, well, thank you, Alex, and thank you, Martina, for these insights into multi-mycotoxin analysis. Let me now steer our discussion into a relevant issue. Once you have test results in hand and you've identified a contamination issue, you're probably going to want to mitigate the risk to your animals. And so with this in mind, let's turn to the audience once again for our final poll question. Over the past 12 months, which mycotoxin mitigation methods have you used? A mycotoxin binder added to feed, a multi-strategy mycotoxin deactivation feed additive, good quality control and feed management? Are mycotoxins not an issue for you, or are you currently looking for a solution? So while you're voting, I'd like to ask you, Alex, another question. Would you tell us the difference between the first two options, so the binder and the multi-strategy approach?
Good. This question always appears. So, in a simple way, what is a binder? A binder is a typically bentonite or clay that is able to bind mycotoxins, especially aflatoxins. And the multi-strategy is more innovative solution containing different strategy to counteract the different mycotoxins, not only aflatoxin. All
right, thank you. With that, we will close our poll. And now looking at the results, seems to be a nice mix here. 44% of you say that you use a binder. 33% of you say that you use a multi-strategy deactivation feed additive. 46% of you exercise good quality control and feed management. 5% of you say that mycotoxins are not an issue for you. And 13% of you are currently looking for a solution. So what would you say about this? What would you say to those who use, for example, only binders?
Yeah, this is another important point. Even if you select a proven and a reliable binder, you have still only solved a part of the problem. Yeah. So the most common mycotoxin in our annual survey, for instance, are DON and FUM. And this mycotoxin cannot be bound properly. Yeah? So we need to add a couple more strategies to mycotoxin risk management to address these less bound mycotoxins, right? So of course, every pharmacy is different, but with your detection result in hand, a BIOMIN technical or representative can help to tailor a mycotoxin solution that best fits your needs, right?
You mentioned that it's probably a good idea, even if you're using a binder, to use a couple of more strategies, right? What would these other strategies be? What would a multi-strategy approach actually look like?
Okay, to explain a bit more about this point, I would like to show the last MYCOFIX generation. So, as we know, mycotoxins have different structures. That's why different strategies are needed for the counteraction. So the MYCOFIX has 3 strategies, as we can see now: absorption, biotransformation, and bioprotection. So absorption via bentonite, it's a proven solution. It's gone through the full process of EU authorization for the binding aflatoxin. And this means that the binding is also proven in real farm conditions. Then we have the biotransformation component containing FUMZyme for the degradation of fumonisins, the BSH for the breakdown of tricotocins, and the MTV components responsible for counteracting zeravenone and ochratoxin. On top of this, MYCOFIX contains the bioprotection component to help and protect the liver and immune system from the effects of mycotoxins.
Oh, you know, there are a lot of products out there. What is it that sets MYCOFIX apart, actually?
It's very important to clarify this. Like we know, we are the first and the only company with the EU authorization for 5 ingredients to deactivate mycotoxin. Since 2013 and 2014, we have the registration for the bentonite for all animal species, and the BBSH and the purified enzyme, funzyme for pigs. And in 2017, we got the registration of BBSH and funzyme for all avian species. So part of achieving EU authorization for the biotransformation aspects was proven that the approach are effective at degrading the target mycotoxins and that they are degraded into non-toxic compounds. So BIOMIN leads this technology worldwide thanks to a true commitment to research and development.
Well, tell me a little bit more about the science behind how MYCOFIX actually works.
Good point. To achieve this registration, there are a lot of requirements to be met. For example, you have to run several trials to prove the safety and efficacy of the products. So BIOMIN has cooperates with leading universities from all around the world, and we also can see here there are several peer-reviewed papers published in this field, and as it's required to prove the efficacy of the product not only in vitro but also in vivo.
What would you say is the correct inclusion rate of MYCOFIX in diets in order to achieve a sufficient level of protection?
Yeah, this is a good point. The inclusion rate depends on different factors, right? First of all, you have to consider the contamination levels as well as the mycotoxins which are occurring in your diet. So it also depends on the production stage and on the animal species. But you can always contact a technical and sales representative from BIOMIN, and they will help you with your needs and help you to find the right solution for your farm.
That's right, and something else that might help, I'd like to point this out to everyone, of course, is the MYCOFIX app. This is available in the Apple App Store and also on Google Play Store, so feel free to download that. It will help you stay up to date on mycotoxins, including regular updates on survey data, similar to the data that we're discussing today.
Yeah.
And with that, we come to your questions. We have a lot of questions to choose from, not only from the questions that have been coming in during this webinar itself, but also from the registration form that you filled out when you signed up for this webinar. So thanks to all of you out there in the audience for your questions and your interest, and also to our fantastic team here working behind the scenes who helped us pick out some questions to answer here. Well, Martina, the first one goes to you. Mm-hmm. How does LC-MS-MS compare to other testing methods, such as ELISA or LFDs, testing strips?
Yes, this is a question that we get really very often. There is one important concept to remember when trying to compare different testing methods. There is no absolute best method. There are only methods that are fit for purpose or not. So the testing method that should be chosen for one application is the one that fits best one's necessities. For example, for a fast screening at the grain collection point, the best method would be a rapid one, like strips or ELISAs. And for multi-mycotoxin analysis that includes regulated and emerging mycotoxins, the best method would be an LC-MS-MS analysis.
That's right. It depends on all these factors. It depends on throughput. It depends on what your budget is. It depends on a lot of different things. Yes. All right. Thank you. Yes, and the next question here, this is for you, Alex. This question is sort of asking you to look into your crystal ball and tell us a little bit about the future. What is the trend of mycotoxin contamination for the next few years? What do you think?
Yeah, well, as we saw in the result of our survey, the tendency is to continue to see high prevalence and contamination by mycotoxin produced on the field, right? So mycotoxins such as aflatoxin may show up again, as we have seen in some regions, such Asia, but irregularly or sporadically. And another important point is also fumonisins are starting to appear more in colder regions, like North Europe. So the great challenge actually is coming from the field, due to the change in climate and agricultural practices that created the environment for the mycotoxin production, right?
I see. So this reminds me of what you were saying earlier about climate conditions in Argentina.
Yes,
right?
yes.
How they differ, how different they were in 2017-18, and the effects that had on deoxynivalenol and fumonisin production.
Yeah.
All right. Thank you. Well, this next question is actually going back to you now, Martina, and it seems that with LC-MS, we've hit on a topic that a lot of people find interesting. The question's pretty simple. How do you take a sample for LC-MS analysis?
Oh, well, the sampling procedure is just like for any other mycotoxin analysis, so it is always of crucial importance that a sample is representative. And this is because, as we know, mycotoxin distribution in grains is typically uneven, so a good rule that applies also in this case is to collect incremental samples as described by the sampling guidelines that are in place in your respective country. But I think the detailed steps that are described in our sampling guide that will be provided to the participants.
This is a question we get pretty often at Romer Labs,
Exactly.
isn't it? Yeah. And one thing that you have to keep in mind is that sometimes these mycotoxins will be found in hot spots, so
exactly
uneven distribution.
That's how they're called, hotspots.
I see. Okay. Good. And this next question goes back to you, Alex. I'm finding contamination from multiple mycotoxins in my feed, this person writes, but the levels are low. Should I still be worried?
Good question. So, like you know, mycotoxin have different effects on various organs and on animal productivity and health. But currently we have a result from several studies showing the impact on the different mycotoxins, especially on the gut and immune system. So we know that if these systems are not working well, they can open the door to several diseases. Almost always, we concentrate our efforts and investments to control disease or low production parameters without consider that the mycotoxin can be present and contribute to these losses. So we need to keep in mind that mycotoxin can affect more than one system, right?
All right. Thank you. Thank you. And speaking of affecting more than one system, this is a question going back to Martina now. You mentioned synergistic effects earlier, and I think that's attracted some interest here because our question is, can you give us a concrete example of synergistic effects between mycotoxins?
Okay, there are many possible examples, but let's take fumonisin B1 and deoxynivalenol. So the effects of the co-occurrence of these two fusarium toxins have been investigated in chickens because, as you know, you cannot predict the toxic effect that will be observed when two or more mycotoxins are present in the same diet just by knowing the single toxic effects of these mycotoxins. Studies need to be performed. So it was found that chickens fed with diets containing both fumonisin B1 and deoxynivalenol had lower weight gain and decreased efficiency of feed utilization. There was also a significant synergistic interaction between fumonisin B1 and deoxynivalenol regarding level of cholesterol in the blood and serum activity of several enzymes, which is a biomarker of liver injuries and liver diseases.
All right, thank you. And with that, we are now coming to the end of the Q&A session and the end of our webinar. As promised, you'll be getting some goodies from us. You'll receive an email with links to today's recording. You'll receive the brand new BIOMIN Mycotoxin Survey Annual Report, a Romer Labs mycotoxin sampling guide, and a link to a short on-site mycotoxin testing video. And all this you'll get within the next 24 hours, so make sure you're checking your email. When we conclude the email, you'll be prompted to answer a short survey about today's webinar. It should take no more than 2 minutes to complete. By providing your feedback, you allow us to improve our webinar program and identify potential future topics for discussion. We would appreciate it very much if you took the time to complete the survey. So it just remains for me to thank our speakers, Alex and Martina. Alex, thank you very much.
Thanks for this opportunity.
Always good to have you here. Thanks a lot. And Martina, thank you.
Thank you very much for your attention.
Thank you. We'll see you at the Mycotoxin Minute over at Romer Labs. And this is Joshua Davis from Romer Labs saying, visit us at biomin.net or romerlabs.com to learn more about how we can help you develop a mycotoxin detection and management strategy tailored to your needs. Thank you for your attention and your interest, and have a great day.